Hello everyone. Welcome back to the course of data structures using C language. This video is brought to you by Newton's Group of Institutions, Macharla. This is Aravind Yegireddy from the Department of Computer Science and Engineering. In the last video, we have discussed how to append the node, that is how to add a node at the end of the single linked list, how to insert the node at the beginning, how to add the node at a specified location. And we also discussed how to find the length of the list and also how to display all the elements in the linked list. Now in this session, let us discuss how to delete a node for implementing the single linked list. So now let us write the logic for deleting the node from the list. And here we need to remember one thing. We can delete the node from the beginning of the list or from the end of the list or delete a node at a specified location. So here we need to consider all the three possibilities while writing the logic. So let us suppose that the function name is delete whose return type is void. Again, let us consider the same example that the list consisting of 4 nodes like this. Say that the root variable is pointing to the first location, first node, and some of the nodes which are already connected like this. Next, we have to see how to delete. Suppose we would like to delete the first node. We are trying to delete the first node. So here, first we have to create a temporary variable temp, which is of struct node pointer type. And next, we need to declare one more variable location, that is int LOC. So first, here to delete, first we have to give the location value, which node we have to delete. So first we are displaying a message saying that printf enter the location to delete. Then we need to scan the location by using the scanf function. Scanf %d ampersand LOC. So into the address of the location, we need to store the value. Say, suppose that you have given the location value as 5. Since the maximum number of nodes in this particular case is only 4 nodes, so if the location what we entered is greater than the length value, the length of the list, so here we are calling the length function directly, or you can pass into an other variable separately by using here, that is len is equal to length. So that you can write here len. For that you need to declare one more variable len. So here we are using that length function directly. So here in this particular case, the location value is 5 and the length will return the value 4. So simply what we are doing, since the condition location value is greater, 5 is greater than 4, we are simply printing that invalid location. And also we are printing the message saying that the list is currently having %d nodes. At this %d, what we are doing, we are directly printing the value by using the length method. So here the length method will return the value 4. So here it will display the list is currently having 4 nodes. Since the list is currently having only 4 nodes and you are trying to delete the 5th node, so that it is printing the invalid location. Else, if imagine that the location what we are considering is 1, then the user want to delete the first node from the single linked list. So here the user want to delete the first node from the single linked list. So we can delete by using temporary variable. So into the temporary variable, we need to assign the root value. We need to assign the root value. So here the root will be now pointing to the first node. So once after writing this particular statement, the root value is 2046. So the 2046 value will be placed into the temp, and the temp will be pointing to the first node. Now it is very simple to delete the first node. Here the root should be pointing to the second node. And here we need to disconnect this. So here we have to place the value null. So here first we have to store the address of the second node into the root. So we have to store this 5048 value into this 2046. So how we can do that? Of course, here if you can notice, the root is pointing to the temp first node, and the temp is also pointing to the first node. So we need to assign temp to link value to root. So now the root will become 5048. So the root will be pointing to this particular node. Now we have to delete this particular first node. So how we can do that? So for that, what we need to do, we need to place the temp to link value as null, so that this particular connection will get disconnected. So temp to link is equal to null. So here null value will be placed and this connection will be lost. So now this node, this particular node is free. So from the left side, no one is pointing. So now from the left side, no one is pointing, and from the right side, it is not pointing to any node. So here we need to remember one thing. I am repeating once again here. We are deleting the node means actually we are just disconnecting its left link and right link. In any programming language, we cannot write any function manually to delete the memory location or information in any memory location. What we can do is we can only overwrite the values, or we can replace with a new value. So here, now we have to release this node by using the free function. So here, free of temp. So to delete the first node from the list, we have to write free of temp. Okay. So now suppose if we want to delete the node from the end or in the middle of the linked list or at the specified location, then what we have to do? We have to write one more else, because to delete the element from the end or to delete the element at the specified location, we can write the logic by using else rather than by going it for else if. Because this simple logic will satisfy deleting the node for both the conditions, that is for deleting the node at the end and for deleting the node at the specified location. If there are no elements, then this particular if block will get executed. If the location is 1, then this else if block will get executed. And if to delete the last or a specified location, then the else block will get executed. Now let us write the logic. Suppose that we have the location as 3. We have given the location value as 3. Then how to delete? So when we give the location value as 3, we have to delete this particular node, that is third node. So how to write the logic? So here we have to declare one more variable I, which is of type integer with initial value 1, and one more pointer variable p with initial value root. Okay, so which is of struct node? Pointer type. So I have taken one more pointer variable p, which is whose initial value will be root. So here now p contains the root value. So 2046 will be stored here. So here 2046 value is stored into p, so that the p will be pointing to the first node. So P contains the root value. That is, the root value is 2046. So 2046 is stored into the P. Now, what we have to do? So to delete this particular node, we need to bring the control to this particular location. So while I less than LOC minus 1. So we need to collect the P2 link value into P. Then we need to increment the I value. So what is P2 link value? P2 link value is 5048. So that 5048 is need to be collected into the P, and I value we need to increment. Now, if you recollect, while adding a node at a specified location, in the while loop, we wrote the logic as while I less than LOC. But here in this case, we are writing I less than LOC minus 1. Why? Because there we are inserting the element or the node after the specified location. So if I give the location value as 3, I am inserting the node after this particular third node. Whereas in this case, when I give the location value as 3, I am deleting the current node, that is this particular location value. So we are deleting the node at this particular specified location. So here, now coming to the logic, here my I value is 1. I value is 1. And the location value is 3. So 1 is less than location minus 1. That is 1 is less than 3 minus 1, 2. So 1 is less than 2. The condition is true. So we enter into the while loop. So P is equal to P2 link. What is P2 link? 2042 to link is 5048. So 5048 will be placed here. Then I value will get incremented. So I value becomes 2. Now again, what we are doing? We are checking the while loop. So 2 less than location minus 1, 3 minus 1, 2 less than 2. The condition is false. The condition is false. That is, the condition fails. 2 less than location minus 1 is, that is 2, which fails. Reason is P is already pointing to this particular location, this particular node. So here the P is pointing to this node. So now we have to come out of this particular while. Now we have to take one more pointer variable Q, which is of struct node pointer type. So Q is an struct node pointer type. So I have taken one more variable Q. Now say that which is here into the Q, what value I have to point is the Q should point to this particular node, the node what we are deleting. So in the Q, the address value need to be 9042. In the Q, the address value need to be 5042. So which must point to this node. So here into Q, we are storing the P2 link value. So P2 link is equal to Q value. So 5048 to link value is 9042. So 9042 will be stored here. So 9042 will be stored into Q. Now I want to delete this particular node. Now here in this case, I want to delete this particular node. So I want to delete this particular node. So first I have to store this 7052 value here, so that the link will establish between this node and this node. So what is this? That is address of Q2 link. Address of Q2 link. So Q is a Q2 link value is 7052. So here I am placing P2 link value as a Q2 link value. So this connection will go from here to here, and this node will get this link will be lost. This link will be lost. Now here we need to disconnect this link also. So for that, what we have to do, we have to place the null value here. We have to place the null value here. So how to place the null value? So to place the null value here, we have to say Q to link is equal to null. So automatically this link also will be lost. So here the null value will be placed and the right side connection will be lost. So now we have to free this Q. So how we can free right means we can write free of Q. So if we Q, then this memory can be reallocated for other purpose. So we can write here one more statement, free of Q. Okay. So if suppose if my location is not 3, my location is 4. So I want to delete the last node. Then how this particular logic is going to work? Let us see. So if the location value instead of 3, if the location value is 4. So when the location value is 4, how this particular logic? So first we are declaring the variable P, which is pointing to the root. So my root value is 2046. So 2046 will be stored into the P. Then for I is equal to 1. So here first the I value is starting with 1. So 1 is less than 4 minus 1. So since we have given the location value as 4 to delete the last node. So 1 is less than 4 minus 1, that is 3. So P to link value will be stored into 2046 to link value will be stored. So here 5048 will be stored. Now after storing 5048 I plus plus, now my I will become 2. 2 less than 4 minus 1, the condition is true. So since the condition is true, again we will place P to link value into P, that is 5048 to link value, that is 7052 into P. So now my P will be having 7052 value. So once after that, I value will become I plus plus, I value will become I plus plus, so my I will become 3. So 3 less than 4 minus 1, 3 less than 3, condition is false. So here the P will be pointing to this particular location 9042. Sorry, not 7052, 9042. So 9042. So here when the P value is 9042, what I am doing? Q is pointing to Q to link. Q is pointing to Q to link. So what is P to link? P to link is 9042. 9042 to link is 7052. So 7052 will be placed into the Q. So once after placing the 7052 value, what we are doing? We are placing P to link is equal to Q to link. So Q to link value we are placing into P to link. What is Q to link value? Q to link value is null. That null value we are placing it into this particular this node. So once when I say this connection will be lost. And Q to link is I am placing null value. Already it is null. Again it will be replaced with a null. So there is nothing going wrong once again after replacing with the same null value. So here already it is null. Again when I say Q to link is equal to null, once again it will be placed with the null value. So this got null value. So here now this particular node is free because this connection is lost. So we have to use the free function for if we want to use reallocate the memory, then we are going to use free of Q. So because here in the linked list, we are using the dynamic memory concept, dynamic memory allocation. So when we are using the dynamic memory allocation, we can use the free function to free the memory so that we can reallocate that memory for other purpose. Okay. So this is the logic what we are going to use for deleting the node either from the specified location or deleting the node at deleting the node of the last node. Okay, that's all for now. Thank you. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thank you.